Good day, guys. I hope you're all doing so well. Ne? On today's lesson, we're going to deal with work, energy, and power. So I welcome you all to my class, grade 12 especially, because this is a physics paper 1 topic for grade 12. Ne? Yes, guys, it is work, energy, and power. So for you to understand this topic properly, you ought to be acclimatized with the drawing of Freiburg diagram, both of an object on a surface and on an inclined plane. You ought to know components of forces. You ought to understand how to simplify problems. Later we'll deal with gravitational potential energy, kinetic energy, and how to simplify problems that involves that type of energies. Now, on today's lesson, we're going to focus mainly on the work done on an object and finding the angle between the force and the displacement only for today. Then in the next part, we're going to deal with more questions that involves potential energy and stuff together with the energy work theory. So this lesson or this topic constitutes 65/150 of a paper 1 physics examination in June, September, and December. So this topic, it will be asked in your June paper 1 examination physics. So be prepared. It's so simple. It just requires you to know the basics, which is what you're going to deal with today. Once you get the basics of today, you'll be able to solve more problems that involves this topic of work, energy, and power. And I'll also assist you guys on how to draw a Freiburg diagram on an object on a surface and on an inclined position. I hope you're gonna learn more on today's lesson. Please join me. Let us just actually start, guys. Now, this is the broader definition of work done on an object. When I can literally resize it. This one is so long. When I can resize it in your own way. Now I'm just putting this one to bring about understanding of this definition of work done and the derivative or how this formula derives from the definition overall. So when I can resize the definition, it is not this too long. Now I've extended it for you to understand more properly and clearly of this topic. Let us just start. This is the definition of work done on an object. So the work done or work, this is the definition of work, actually, not work done, work in general. Work is the work done on an object by a constant force. So now F is, basically before you can do anything, you're expected to write the work done on an object by a constant force. Then I come constant force F, which means our force is denoted by symbol F. You stop there. You're not going to write this formula. You don't write that formula. Sharp. So now the work done on an object by a constant force F is, which means this is the formula for work done. The formula for work done is F times C change in X times cos theta. This is the formula for work done on an object. Now when you come again, where F is the magnitude of the force, change in X is the magnitude of the displacement, and theta is the angle between the force and the displacement. Note this last portion of the statement. So guys, this basically explains what these three components or these three symbols, what are their functions on the work done on an object? Which means F is the magnitude of the force acting on an object. Changing X is a displacement. Basically, displacement is the distance or the length of the object from point A to point B. This is the length. And theta is the angle between the displacement and the force, or the force and the displacement. Note this. We're going to emphasize more on finding angle theta. So please note this last statement that talks about theta as the angle between the force and displacement. Please note that we're gonna talk more of this angle, how to find this particular angle between the force and displacement. Please guys, note and memorize the last statement. So when I can resize this definition properly, you understand it. Let me just write the broader definition of, or the formula for work done on an object. So it's W equal to a force changing X cos theta. Now, what does this definition stands for? W is for our work done measured in joules. Then F, it is our force measured in newtons. Then changing X, it is our displacement measured in meters, the length. Then cos theta is the angle between the force and displacement. Now, cos theta is so important in this function. Let me just explain the concept of cos theta, or the theta on its own. Theta as the angle. Theta, this theta is so broad. This theta, it consists of two work. Remember, work is measured in joules. Work is energy. Energy on an object, and energy it's either increases or decreases. Energy is either positive or negative. It has no direction. It's a scalar quantity. So theta, and so angle theta explains it gives us if our energy is positive or negative. And when we say our energy is positive, it means our energy is increased. When our energy is negative, our energy is decreased, or the work. Positive work in negative work. Positive work, our energy increases. Negative work, our energy decreases. So the angle theta plays that role of telling us if our work is positive or negative, or if our work is increasing or decreasing. So it consists of two components. Let me just remove this there. Positive work and negative work. So I'm going to explain these concepts of positive and negative work in the next example of a diagram. I'm going to explain this concept now. Let me just draw a diagram. Here's a diagram. An object. Let me just say this object is on a surface. A force is applied here. Maybe a force of 20 newtons is applied here. And this object moves from this point to this point. Maybe this object is going to move 3 meters from this point to this point. Now the force is applied here on this box. Now the question will say determine the work done on all forces acting on this object. Guys, how will you find work done on all object acting on this object? You have to understand how to draw a free body diagram before you can do anything of this box. Let me just draw it for you so fast. So what are forces acting on this object? We have applied force, we have normal force, H, we have our normal force, and our weight. Normal force, force applied. There are 3 forces acting on this object. Hope you understand. Now let's find the work done on each of the following forces. On force on gravitational, normal force, and force applied. Let's find work done on force applied. Work done on force applied is equals to force change in x cos theta equals to, what's the value of F? 20 newtons. Force applied, what's the value of change in x? 3 meters. Then what is the value of theta? The value of theta, you come back here when I'm going to explain this positive or negative work. Let me just write something. Let me just write particular definitions that you need to understand, that you need to put in your mind until you finish this topic. So you must note that cos 0, you must note cos 90, you must note cos 180 degrees. So obvious, cos 0 is 1, cos 90 is 0, cos 180 is negative 1. So must please put these three angles in your mind. So that's where the positive and negative work are going to derive from this. So now, if our work is positive, that means that our value is going to be 1. And if our work is negative, our value is going to be negative 1. How will you know that I need to put 1 and negative 1? If and only if the force and the displacement acts in the same direction, you will know that this is a positive work. But if the force and the displacement, they work in the opposite direction, that means our force is going to be negative. And in this case, we have the force and the displacement. They're acting in the same direction, that means our force or our work is positive, that means the value is going to be 1. For theta is going to be 1 here. Because of what? Our displacement is going to this direction and our force is going in this direction. I hope you understand that clearly. But now, let me just explain on a diagram. How will you know that our force is positive or negative? Let me just put my marker here. Remember, guys, this arrow represents the direction of the force. And obviously, this type of drawing represents our displacement. These two forces, I mean, the force and the displacement, they are both on the same on the surface. They're just being shown. They are represented on the diagram, but force and the displacement are literally on the same line here, on the surface of the object. Basically, on this line, on this black line, we find the force and the displacement. Displacement is even extended, and obviously force, it starts from here. Even the force starts from there. I hope you understand me what I'm talking about. This arrow just explains what a force is applied here, and this is being shown what there is a displacement. But these forces, they are on the surface. That means our object is here, and this force is on the surface. Both of them. Now let us find what theta is the angle between the force and displacement. Where is our force? Our force is on the surface. Where is my displacement? Our displacement is also on the surface in the same direction as the force. That means if I put my marker, this pen, on my force on the surface, and I need to find the angle between the force and the surface and the displacement. What's the value of that angle between the force and our displacement? Since well now our force is on this line and our displacement is also on this very same line as our force, is 0. There's no angle. The angle between force and displacement is 0. I cannot move my pen here. That means the value of theta is 0. Hope you understand. There's no, meaning I need to find, I am measuring my angle between my force and my displacement. I hope you understand what I'm talking about here, guys. Here I'm measuring the angle between force and displacement, and if I measure it properly, it is 0. Since well now my force and displacement are on the same surface, which is this surface. I hope you understand it. Then 20 times 3 is 60. It's positive work. So this positive work does not mean direction. It means that our energy is increasing. Remember, energy is our scalar quantity. So this positive sign does not mean that the direction is increasing. It talks about energy that increases, hence the joules. And yeah, I hope you understand, guys. Now let us find work done on normal force. Work done on normal force. On normal force. then normal force, change in x, cos theta. What's the value of normal force? Let me just say my normal force here. Let me just not put it. It's not important. Yeah, it's not important. Let me just say I'm just trying to show you how to find theta in this case. If they say you must find the normal force, write down on normal force. Let me just denote it like that. Then you have 3 meters here. Then cos. What's important is the angle there. How to find the angle between the normal force and the surface or the displacement. So from this diagram, let me just draw my normal force here. Okay, it's already on the Fourier diagram. So use my normal force. Now, remember how to find theta or theta. Theta is the angle between the force and displacement. How to find that angle? You put your pen on normal force and find the angle between normal force and displacement. Where is my displacement? My displacement is right here on the surface. Where is my normal force? Normal force is here. Now let me just measure that angle. Now guys, it starts from normal force, it goes to the right. Normal force. Can you see that angle between normal force and displacement? It forms a perpendicular line. Remember, normal force is perpendicular to the surface. And now I can measure the angle. The angle between normal force and displacement is 90 degrees. I hope you can see it. Here's my angle. Here's where my 90 degrees comes from. Normal force. Here's my displacement. Normal force and displacement 90 degrees. I hope you understand it, guys. That's how you measure the angle. Then obviously this value of cos 90 is 0, then 0 times all this value is 0 joules. This will apply on a weight, work done on the weight. I hope you understand this topic. How about if we are given let me just say we have on the box, they provide us with frictional force. Let me just say 10 newtons. Then we say find work done on frictional force. Let us find work done on frictional force. 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 Frictional force. Change in x. Cos theta. What's the value of frictional force? 10 newtons. What's the value of change in x? 3 meters. Cos. What's the value of theta? Very important. Now, remember, theta is the angle between the force and displacement. Our force is frictional force and our displacement is on the right. That means frictional force acts opposite to our displacement. We said if the force and the displacement are in the opposite, that means that's negative work. That's an opposition, opposite angle of one another. Now we need to, I'm going to put my pen to find theta. Remember, theta is the angle between my frictional force and my displacement in this case. So I'm going to put my pen here and find the direction at which my displacement is being displaced. If I put my pen on the direction of my frictional force, I need to find the angle between my frictional force and my displacement. Basically, this pen needs to be in the direction of my displacement from the frictional force direction. It's on the left, then I go to the right. Since where my displacement is on the right, I'm going to put my pen on the surface of the frictional force, and that's it. Here's it. Guys. Change starts from the left to the right. Left, right, left, right. So what is the angle between this side and this side? If we measure properly with a protractor, mathematically speaking, the angle between my left side, the angle between on this side, and you can remember it starts from the left, it goes to the right. It starts from here to my normal force 90, and from my normal force to my displacement is another 90. It means 180. I hope you can see it. If I can draw my Fourier diagram properly here and show you. Here's my frictional force applied, and it has got my displacement here, 3 meters. Now The angle, what's the angle here? Is 90 degrees and it's 90 degrees. That means if you add the 2 is 180. So I put my pen here, 180, and from this side to this side is 180. And on this side, this is where I find my displacement. Remember, angle between force and displacement, angle between frictional force and displacement is 180. I hope you can see it, guys. Now 180, write it here. This is how you know what you need to put in -1 or 1 by measuring the angle between the force and displacement. Now 10 times 30 is negative. 10 times 3 is negative 30. Negative 30 times -1 is negative 30 joules. Negative work. You understand, guys? Hope you understand this concept of positive and negative work. We're going to deal with such questions thoroughly going forward. Let me just make an example. Another example about how to find theta. Now I'm going to include an angle, a force acting on an angle. Yeah. Let me just remove on this side. Yeah. So I hope you guys are still clear. Hope you're still clear. If you're not clear, please comment in the comment section. Yeah. Yes, guys. So now let me just make an example. So I'm just gonna take it from the previous exam paper. So you have a surface in a box. This box at force applied here at an angle here. You have a force of, let me just say, 100 newtons. So this force acts at an angle here. At an angle. At an angle of 30 degrees. And my displacement is 3 meters. And so it says like this, and frictional force is applied here. Frictional force is equal to 10 newtons. Now they say that an object, here's an object that has got two forces, frictional force and force applied. And force applied acts at an angle, which means this person is pulling this object at an angle of 30 degrees. And it's pulling to the right 3 meters to the right. Now frictional force is applied on this object. Calculate the work done on all forces acting on this object. I hope you understand it. Let me just draw my Freiburg diagram before anything else. Here's my Freiburg diagram, guys. Force applied, frictional force, Fg, couple weight, and my normal force. Now let us find all work done on all forces acting on this object. So number 1, let us find work done on force applied. So it's force applied, changing x cos theta. What's the value of force applied? 100 newtons. What's the value of changing x? 3 meters. What's the value of cos theta? Now let us find the angle between, remember, the angle between our force and our surface, which is our displacement. The angle between the force and our displacement. What's the angle between our force and displacement? Remember, you put your pen on the arrow of our force and check the angle between our force and our displacement. Guys. Here's our surface. Our displacement is here and our force is here. What's the angle between our force and our displacement? Force, displacement. Let me just draw. Here's our angle. It's 30 degrees. So I'm just extending some. I'm just showing you on the Freiburg diagram so you can understand it. What is the angle between our force and our displacement? Force, displacement. force displacement 30 degrees. Hope you can see it. So now you're gonna write 30 here. And yeah guys, then please find me the answer there. I'm not in position of my calculator. Not in position of my calculator, so it's 100 times 3 is 300. 300 times 1 over 2. I don't know what's cos 30. I think it's square root of 3 over 2 if I'm not mistaken, or 1 over 2. Yeah, I think it's square root 3 over 2. I'm not sure guys, please I don't have my calculator right now. Just find the value here, but obviously it's going to be positive work, and yeah, hence the force applied, hence the displacement is in the same direction as our force. So I hope you can see how to find theta. Ne? Please guys, acclimatize yourself with how we find theta the way I do, because it's so simple. Ne? Let's find work done on frictional force. Work done on frictional force. Let me just write WF. Ne? Frictional force, change in X. Yes. The space is so small. 902. Work done on frictional force, change in X, cos theta. What's the value of frictional force? 10 newtons. What's the value of change in X, or my displacement? 3 meters. What's the value of theta? Now let us find the value of theta. Remember, theta is the angle between the displacement, the force and our displacement. Okay? So where's my force on my left? Where's my displacement on my right? What's the angle between my frictional force and my displacement? Neighbor, starts from the left to the right, left to the right, left to the right. Even if you can start on this side, on my left to the right, left to the right. Meaning it starts measuring from this point to this point. The angle 180 degrees. I hope you can see it, guys. I hope you can see it. From this point to this point, if you measure this angle with a protractor, it's 180 degrees. I hope you understand. 180 degrees. That's how you will know which angle or which value to put on your theta. So 10 times 3 is negative 30. Here, negative 30 joules. Remember, cos 180 is negative 1. Negative 1 times 30 is negative 30 joules. Negative work. Hope you understand it, guys. Now, normal force, Fg are the same values. So our theta is going to be 90. So normal force and frictional and Fg, the answer is exactly the one we did in the previous example. So there's no need for us to go through that process of finding normal force and Fg. They are the same as the previous question. It's going to be 0 joules, the answer there. So there's no need for us to go through that process. Let us do an example of a force acting on an inclined position. Very simple. Yes. Object on an inclined plane. So guys, here's a question. An object on an inclined plane. So we have a crate with a mass of 10 kg is pulled 4 meters up on an inclined plane that makes an angle of 30 degrees. Here a diagram with the ground. The crate is pulled with a force of 180 newtons and experiences frictional force of 10 newtons. Calculate the work done by each of the forces on the crate. So we have force applied. We're gonna find the work done on force applied, work done on frictional force, and all other forces that you're gonna find when drawing our free body diagram. Remember, before solving this type of question, you ought to understand how to draw the free body diagram. Let us draw our free body diagram, guys. Free body diagram. We have. Remember, it's a box it's a crate on an inclined. So we have our force applied. We have our frictional force. We have our normal force. We have our weight parallel. Gravitational force. we have our weight perpendicular, so it's FG perpendicular, FG frictional force applied, and our normal force. So you can include parallel force, no problem with it. You can include parallel force. Obviously, it is also on this position, so you can include parallel force here. F parallel, FG parallel. Okay, so these are all forces acting on this object when it is going up. So now we need to find work done on all forces acting on this object. Let us start with force applied. Number one, work done on force applied is equals to force applied change in x cos theta. Remember guys, they're not saying work done on net force, they're saying work done on all forces acting on the object. So there's a difference between work done on net force and work done on forces. So there's a huge difference there. Remember that. What's the value of F applied? 180 newtons. What's the value of change in x? 4 meter. Then what's the value of our theta? Remember our angle theta. How are we going to find it? Remember our ground, or our angle theta is the angle between the force and the displacement here. So if you look at this diagram, our displacement is going up in the same direction as our force. And what is the angle between the force and our displacement? I taught you how to find the angle between the force and our displacement. You put your pen where our force is directed to and our displacement, so do our displacement. Then the angle between our displacement and our force, remember our displacement is right here. Even our force is right on the surface of the grid. That means it's zero there. The angle between force applied and our displacement is 0. If you can look at this, remember our displacement, the 4 meters here, is on this line of force applied. Our displacement and our force applied are on the same arrow, this one. What is the angle there? It is 0. There's no angle there. I hope you understand me, guys. There's no angle between our force applied and displacement. It is 0. Because they're in the same direction here. So you write 0 there. Not that, please, guys. Then you can find the answer there. I don't have my calculator. But I think I'll just use this thing. So it's 180 times 4 is 720 joules. Then you are done. Positive work. Obviously, I told you about positive work and negative work. Number 2, we cannot find work done on frictional force. Work done on frictional force is cos the frictional force, change in x, cos theta. What's the value of frictional force? 10 newtons. What's the value of change in x? 4 meter. What's the value of our theta? The value of our theta, same thing now. We just measure the angle between the force or frictional force and the displacement. Where is our frictional force? On our left hand side. Where is our displacement? On our right hand side. So they're in the opposite direction. Therefore, this is the negative work. Okay? Frictional force and displacement, they're in opposite direction. Therefore, if you measure this angle, you put a pen on our frictional force, you measure it here. And up until, and this pen must be faced in the direction of our displacement. So from the left frictional force to a displacement 180 degrees. I hope you can see it. Even from the diagram is from the left to the right. The angle is 180 degrees. So it's going to be a -1. Actually, it's going to be cos 180, not -1. Cos 180. Then obviously it's going to be 10 times 4 is 40. 40 times cos 180 is negative 40, because cos 180 is negative 1. Yes, I hope you can see it, guys. Yes, that's how we do it. Number C, we want to find our work done on FG, or gravitational force. Work done on FG is equals to FG change in x cos theta. Then FG is, again, is our gravitational gravity, mg, mass times gravity times change in x cos theta. So you need to write in that order here, guys. Then what is the value of our mass number? Is 10 here. What's the value of our gravity? 9.8. What's the value of our displacement? 4 meter. What's the value of our theta? Very important, this one. Now let us check our I need to draw something. Let me just, so let's come back here. We need to find the angle between gravitational force and our displacement. I hope we can literally see it, guys. Let me just remove this thing and draw a proper one. I want to show you something very important when you want to find the angle between displacement and gravitational force. So yeah, I'm going to draw. There is our box here, and here our angle is 30. Then I need to draw here. So I'm literally drawing this theme on the diagram. So I just want to show you something. Then we have our force, our frictional force. So it's normal force, Fg perpendicular. Then we have our gravitational force, force applied, frictional force, and we have for F parallel. In grade 11, you learn that this angle here is 90 degrees. Yes, you learn that in grade 11. And you learn again this angle between gravitational force and gravitational perpendicular and our perpendicular line, Fg perpendicular. The angle between Fg gravity and Fg perpendicular is the first same angle as this one, 30 degrees. So the angle here is 30 degrees. I hope you can see it, guys. Then now, since we're now normal, our normal force is perpendicular to our displacement or our force applied. So both the normal force and the Fg perpendicular are perpendicular to the force applied. Therefore, the angle, let me just show you the different color. The angle here, the angle is 90 degrees. Normal force and angle between normal force and force applied is 90 degrees. And also the angle between Fg perpendicular and F applied or displacement is also 90. The angle from this line to this line is 90 degrees. I hope you can see it, guys. Now remember, theta, when you want to find the angle theta, in this case, the angle theta is the angle between the force and our displacement. In this case, it's the angle between Fg and our displacement. Where is our displacement? Here on this line of together with our force applied on this line. Now let me just measure the angle between this line and this line, these two angles. Let me just measure them. It is angle between Fg and our displacement. As we go back to the definition, we said to go to the angle between the force and the displacement is theta arrow. Therefore, the angle between Fg and our displacement, it is found right here. So what is the value of this angle? We said this angle angle between Fg perpendicular and displacement is 90 degrees. Therefore, if I can measure that angle there, I want to say 90 degrees, this one plus 30 degrees is 120. Therefore, I'm going to write 120 here. I hope you can see it, guys. So I'm gonna write 120. Yeah, 120. This is the answer. Yeah. Then if you put on a calculator, I don't have my calculator currently, so Mark is gonna give you a positive answer. Then you are done. Yeah, boy. I hope you can see it, guys. Or alternatively, so yeah, I think yeah, that's how you do it, guys. That's how you do it. So how do you find this angle? Alternatively, you can find this theta angle by saying okay, theta is equals to 90 degrees plus bottom angle. To avoid going through this process, you can just rather say if and only if. It's like if you want FG, just say 90 degrees plus 90 degrees plus 30 degrees, 90 degrees plus our bottom angle. You only say plus if and only if our grid is going up. Note that. Yeah. Then number three, it is work done. I think it's number 1, 2, 3, number 4, the last one again, because normal force and FG perpendicular is going to be 0, obviously, because it's going to be cos 90 here if you put on theta there. Then number 4 is FG with work done on FG parallel. Yeah. I'm just putting it for this. I'm just going to show you how do you calculate it. So it's FG parallel changing x cos theta. So I'm going to remove this part there. Yeah. Just so I'm removing, guys, here, so they can read it properly. Number 4, FG parallel changing x cos theta. Remember, FG parallel is a component. It's force that operates at the parallel, that is parallel to the surface. So it's going to be mg parallel mg sin theta. So this is the formula used to find FG parallel in all sectors. If you want F net, you must FG parallel is always mg sin theta all the time. Changing x cos theta. Then this last two they are included if only if you want work done on FG parallel. So it's very important to put this last two to include our work done. Here you want work done on FG parallel, so you want to include them. If you don't include them, get it wrong. What's a bit of mess? It is 10 kg, 9.8 sine. What is our value of sin theta? 30 degrees. This one does not need any does not need any debate. What's the value of it? Is straightforward, 30 degrees. Changing x. What is our value of our displacement? It is 4. The value of our theta. Now theta will find it. You literally check, okay, what is the angle between, remember our FG parallel is going downwards. Note that, downwards. So if it is going downwards, we need to find the angle between our FG parallel and our displacement. So our answer has to be negative in some case. Let us just test it. So now we want to say, okay, between, and here we have our FG parallel here. Yes, let me just show you from this diagram. We have FG parallel here, and we need our marker to face on our right, from the left to the right, from FG parallel to displacement. And let's just do that. So it's going to pass which angles? It's going to pass which angles? So it's going to pass this 90 here, and this 90, or it's going to pass. Let me just say, let me just check something. So remember, we have our 90 degree angle, we have our triangle here, and here we have a triangle. So inside this triangle you have 90 degrees, 30 degrees, and interior of triangle you got 180. 90 plus 30 is 120. 120, one have 60 here, so that you can have interior of triangle being equal to 180. And then you're gonna have 60 degrees, and our marker needs to be displaced in the direction of the displacement. So from here we go this direction here, up until here. So you're going to count the angles from our FG parallel to our displacement. You can start from the bottom or on top, it's not a problem. So we're going to have 60 plus 30 is 90, 90 plus 90 is 180, therefore it's going to be cos 180. Cos 180. I told you answers must be negative, so we must put this in the calculator. Since well now we have cos 180, when I have negative, you put the answer in the calculator, joules, then you are done. And you are literally done. So guys, if our box was going downwards, and here since well, if it was going upwards, we said if you want theta, when you want to find a gravitational force, you want to just literally find, if you want the theta here on FG, then we're going to say theta is equal to 90 plus bottom angle. And if you want to find FG, if our box was going downwards, and here in this case it was going upwards, hence we said 90 plus bottom angle, which is 30 degrees. If it is going downwards, you're gonna say theta. If you want FG, work done on FG, this one, and I say theta is equal to 90 degrees minus bottom angle, then you are done. I hope you understand me, guys. Thank you very much for now. This is our part 1 of work done, work, energy and power. In the next video we're going to deal with gravitational potential energy, where you're going to find kinetic energy, potential energy, and all those stuffs. Then part 3, the last part, you're going to deal with work energy theorem. Thank you very much, guys. Enjoy your day.